The quadratic formula. This is the second lesson on solving quadratic equations using the quadratic formula. We're going to start with an example, and then you'll see what the new part of today's lesson will be as we go through our example. All right? Now, the first thing you got to remember is to be able to solve a quadratic equation using the quadratic formula, it has to be written in a certain form. And that's ax squared plus bx plus c equals 0. Must be written in that form. And remember, the equals 0 could be at the beginning. It could be 0 equals ax squared plus bx plus c. All right? The next thing is, so we'll look at our equation, and we'll see that it's written in that form. So let's identify our a, b, and c. Our a is 5. Our b is -2. And our c is 1. Okay, so now we're going to start plugging in those numbers into the quadratic formula. So we'll start out by saying x equals the opposite of b, and b is -2, plus or minus the square root of b squared, b again is -2, squared, minus 4 times a is 5, and then times c, and c is 1. And we're going to put that over, or that's all over, 2 times our a, and our a is 5. Okay? So let's start simplifying this a little bit, and you're probably going to see where the issue is pretty quick. The opposite of -2 is 2, plus or minus the square root, -2 squared is 4, minus 4 times 5 times 1 is 4 times 5 is 20, times 1 is 20, and that's going to be all over 2 times 5 is 10. Okay? Now let's simplify this a little bit further, and notice that inside my radical, 4 minus 20, that gives me -16. So we're going to write x equals 2 plus or minus the square root of -16 all over 10. Now you may have recognized the issue. The issue is this -16 under the radical. Right? We can't have a negative under the radical for the solution to be real numbers. So we're not going to have a real number solution here. We're going to have an imaginary or complex solution. So we got to remember how we fix this. So let me get a different color pen. What we do is we take the square root of -16, and if you remember, we're going to rewrite it as the square root of -1 times 16. Now the square root of -1 is just I, and the square root of 16 is 4. So this just makes 4i. So that's what I'm going to write over here now. I'm going to write this as 2 plus or minus 4i over 10. Alright, and let's simplify it just a little bit more. Now, we have a property in math that says if I have two things added together or subtracted in the numerator over one denominator, I'll write them both as fractions. So I can write that, and I can write that. So let's go ahead and do that. I'll have 2 over 10 plus or minus 4i over 10. And that equals 2 over 10 reduces to 1/5. That's our real part of our answer. Plus or minus 4i over 10 is going to reduce to 2i over 5. And that's the imaginary part of our answer. And then we'll go just a little bit further, and we'll split up the positive part, the plus part, and the minus part, and write it like this. X equals 1/5 plus 2i over 5, or x equals 1/5 minus 2i over 5. Okay, so the issue here is that we have an imaginary part of our solution, so we say these are complex solutions. And just for your information, anytime you have complex solutions, there's going to be two of them. So it's going to be two complex solutions. We'll talk more about that tomorrow in the discriminant lesson. Okay. If you had any questions about this, or if you want to look through it again, just rewind the video and watch this part again. I'm going to ask that you go and see if you can work one yourself. I've got the hidden example here, and I'm going to ask you to put your answers in the WISC document. So go ahead and work this, complete the WISC document, be ready to do some of these problems when you get to class tomorrow.